Hello, my fair weather physics students. I am about to show you a problem. And last time we talked about vectors and how to add vectors, and we add them tip to tail, and we get a resultant vector, it's called. And that resultant vector, of course, since it's vector, needs to have direction. All right, so let's go ahead and talk about a little scenario. So let's say I have a guy who's walking along through the woods. So there's woods, so we got to have some trees. There's some trees. There's a boulder in the distance. And so he's walking along, and and just out of nowhere, a big bear jumps out. So the bear's got big, huge paws and a big open mouth and big scary eyes and some ears, and there's teeth, right? And so there's the bear, and he's standing up on his two hind legs, and he's like, "Rah!" And this kid over here is like, "Oh no!" And let's see, what should we call this kid? So let's call this kid Tommy. And so Tommy said, "I'm too young to die. I shouldn't get eaten by a bear. That sucks." And so the bear's like, "Rawr, I'm going to eat you." And this is like a mutant bear, and he's just all messed up. And so Tommy says, "I'm not going to go down that easy." Well, actually, Tommy talks more like this. "I'm not going to go down that easy." And so then he runs over, and he runs over, and he jumps on the bear, and jumps on the bear's back, and he puts him in a chokehold. So Tommy's on the bear like this, and he's choking it, and he's like, "Ah!" And the bear's going, but the bear's pretty strong. So the bear takes off running, and so let's say that the bear, he starts running, the bear is running, and so let's say this is a map of the woods, and so the bear starts running, and Tommy's trying to choke it out, and the bear's running, and he gets 5 kilometers. He runs south for 5 kilometers, right? And so Tommy's still hanging on with this bear running for 5 kilometers south, and so there's one of our vectors right there. So we got 5 kilometers south vector, and Tommy's starting to get weak. He can't hang on anymore, and the bear knows it, and he's going to keep running south, and so Tommy quickly grabs his cell phone out of his pocket and texts his friend Jacob, and he says, "Help me, I'm trying to choke out a mutant bear, and he's running south." and so Jacob says, "Be right there." And so Jacob comes out, and so let's say that this is Jacob now. And so Jacob sees the bear, and the bear's running at him, and Tommy's on its back, and Tommy's choking him out, and Jacob sees the bear, and he goes, "Ah!" But Jacob has like this big beard, right? And Jacob kind of looks like he kind of looks like a Viking sometimes. And so he has his battle axe. There's his battle axe right there. And so the bear's running at Jacob, and he takes his battle axe and he swings his battle axe and he severs off the bear's leg. So the bear's leg is severed off. He's like, "Ah!" The bear's, and then Tommy's choking him out. And the bear doesn't stop, and so the bear. If this is the point where Jacob severs its left leg up, the bear then changes direction and goes southeast for 4 kilometers, and Tommy's almost can't hang on anymore, and finally the bear is bled out after 4 kilometers going southeast, and dies. And so Jacob runs and catches up finally with Tommy, and Tommy gets off the dead bear, and they skin it and cook it for dinner, and they wear its hide, because that's awesome. And so now they're trying to figure out, well, okay, so here we are, we went 5 kilometers south, and then 4 kilometers southeast. So where in the world are we right now? And Tommy says, "I know. All we got to do is figure out the resultant vector, and so Jacob says, yeah. So what they do is they set to figuring out. They said, okay, we learned in physics class we got to put this tip to tail. So here's a tip, and then here's a tail of the next one. So if this is south, right, and then this is going to be southeast or southwest. So sorry, I did this exactly backwards. Okay, we gotta erase that guy. Oop, come on, erase. So southeast, I drew this the wrong direction, didn't I? Should be like this. All right, so southeast, so here's southeast right here, right? Having trouble with my pen. All right, so we got southeast right here. So how do we figure out, so here's the resultant vector then. Let's draw this in a different line. So the resultant vector is going to go from the tail of one to the tip of the other. And so this would be their actual displacement from the bear. And so we know that, that this vector right here is 5 kilometers, and this vector right here is 4 kilometers. All right. So what is the resultant of this situation? All right. So if we were to sort of analyze this angle right here, we know this is going to be our R, right? And this is going to be our A, and this is going to be our B. And we can tell from this angle that it's not a 90-degree angle, so we can't use Pythagorean theorem. We're probably going to have to use the law of cosines in this. But what is this angle right here? So what is southeast? Well, if east is right here, that would have been a 90-degree angle, right? And so southeast then is going to be halfway in between that and south, right? So then this angle right here is going to have to be 90 degrees plus another 45. So say this is 90, and then this is going to be 45, giving us a total angle right here of, and this is a little bit sloppy, but it's 135 degrees, right? So let's go ahead and plug in our numbers that we know so far. So we know that the law of cosines is going to be r squared equals a squared plus b squared minus 2ab times the cosine of the angle between them. And so let's go ahead and do this. So we got r squared, and we want to figure out our resultant. We know that a is, that turned into an 8, I'm not sure how. A is 5 plus 4 squared minus 2 times 4 times 5 times the cosine of 135 degrees. All right, so if we do that, and one thing that is kind of important and that might come up for you is that when you're doing sine, cosine, and tangent, make sure your calculator is in degrees and not radians, because you'll get a different answer if it's in radians. So make sure that you go to mode, look at your calculator, and make sure it's in degrees. Otherwise, you'll keep getting the wrong answer. You'll be frustrated. So if you calculate this right here, it ends up to be like 69.284. And so that's r squared equals 60 squared equals 69.82. So if I take the square root of that, I get r equals 7. No, wait, no. What is it? 8.3, sorry. Couldn't read my calculator. 8.32 kilometers. Okay? And so where are they? So they're 8.32 kilometers southwest. We could say that. We could say 8.32 kilometers. So at this point they're, southeast, sorry. So at this point they're 8.32 kilometers southeast, right, of their original point. And so, or you could use that angle to define it or whatever, but this is good enough. So this right here would be my resultant vector, and using the law of cosines to sort of figure out a more complex situation. Whenever you have an angle over 90 degrees, you want to use law of cosines. If you have an angle that is 90 degrees, you can use the Pythagorean theorem. So hopefully that helps, and we're going to get into some more complex adding of vectors and resultant vectors in the next video.